All right, we're going to talk about the atomic structure answers. You were supposed to answer 1 through 6 and 9 and 10. So number 1, it says list the charge, the mass, and the location of each of the 3 subatomic particles found in atoms. So I think the easiest way to do this would be to make a table. So we'll say charge. Let me make a column first that says particle, charge, mass, and location. So proton, neutrons, and electrons are the 3 particles. The charge, proton, it starts with a P, so it's positive. Now the neutrons, I always have people get confused on this. It starts with an N, so it's neutral. It sounds like neutral. An electron then is negative. For the location, we'll come back to the mass here in a second. A proton is found in the nucleus. A neutron is in the nucleus. And an electron is outside the nucleus. For the mass, I'm going to have to look these up. The mass of a proton is 1.67 times 10 to the negative 27th. Kilograms. A neutron is the same way, same mass, 1.67 times 10 to the negative 27th kilograms. And an electron is 9.11 times 10 to the negative 31st.
Sarah near, call 1102, please.
So that answers question number 1. That's the charge, mass, and location of each of the 3 subatomic particles. Number 2, how can you use an atom's mass number and atomic number to determine the number of protons, electrons, and neutrons in the atom? So I'm going to erase this and put number 2 up here. So the atomic number equals the number of protons which equals the number of electrons. I'm going to put E minus for the symbol for electrons. The mass number equals the number of protons plus the number of neutrons. And so what we can do is we can say mass number minus atomic number equals the number of neutrons. Number 3, identify the subatomic particle used to define an element and explain why this particle is used. The subatomic particle used to define an element is the proton. And the reason why if the number of protons change, the element changes. Then number 4, explain why the masses of atoms of the same element may differ. They differ because the number of neutrons may differ. And those are called isotopes. So atoms of the same element with different numbers of neutrons are called isotopes, which we're going to get into here on number 5. 5 says, and I'm going to move this up a little bit, calculate the number of neutrons that each of the following isotopes contain. Use the periodic table to find the atomic numbers. So I'm going to erase 2 through 4. We'll put 5A is carbon 14. So that's the mass number right there. So if we look at carbon on the periodic table, which is right here, you can see carbon has an atomic number of 6, which is also the number of protons. So we want to know the number of neutrons. So if we take 14 minus 6, you get 8 neutrons. Letter B, nitrogen 15. So we'll do the same thing. Find nitrogen. Nitrogen is right next to carbon. It has an atomic number of 7. So if we take 15 minus 7, you get 8 neutrons. Letter C, sulfur 35. So this is going to be 35 minus the atomic number of sulfur, which sulfur is 16. So 35 minus 16 is 19 neutrons. And then letter D, calcium 45. So we're going to take 45 minus the atomic number of calcium, which is 20. So 45 minus 20 is 25 neutrons. Number 6, identify the unit that's used for atomic masses. The unit used for atomic masses is called the AMU, or atomic mass unit. And I'm going to say that that's about equal to, it equals 1 proton or 1 neutron. We didn't do 7 or 8, so we'll skip over to number 9. Number 9 says if an atom loses electrons will have an overall charge. Well, electrons are negative, protons are positive. They start out with an equal number of each. If you lose electrons, you're losing negative charges, so the overall charge is going to be positive. So losing electrons equals losing negative charge. So overall charge is plus, or it is positive. And the last one, number 10, predict which isotope of nitrogen is more common in nature, nitrogen 14 or nitrogen 15. Well, to find this, we're going to look at the average atomic mass. So if you look at nitrogen's average atomic mass is 14.0067. That's closest to nitrogen 14. So we're going to put on number 10. Nitrogen 14 is the most common.